everyone, welcome to another segment of Loremaker's Guide to the Galaxy. If you are unfamiliar with this, this is a look at the Star Citizen universe. A member of the lore team goes through a system, we discuss science and story ideas, and we talk about the direction we want systems to go, so that they will one day be available for you, the player, in exquisite space detail. So today, we have Earth right here. There it is, very shiny. We're going to do TAMSA. So let's go. TAMSA is the only known system that has a black hole at the center. Now, a black hole is a region of space-time that exhibits strong gravitational effects and nothing can escape from inside it, which includes light, electromagnetic radiation, particles, Big Benny's machines, potatoes, photons, that kind of thing. So we got a little corona of captured light here that Turbulent created, which I think looked pretty cool, honestly. So TAMSA was discovered in 2943 by Banu explorer Kofi Bet Thelma, and they named the system after a math artist called TAMSA Wheel. Like, that's her art name that she picked for herself. Her art has been described as mathematical poetry. It has also been described as a beautiful precision of a beautiful nexus of precision and chaos. That's what the critic said. Yeah. And I think that's pretty appropriate for a system with a black hole in the center. All right. Now, back to black holes. I used to think that black holes were kind of scary. I thought they were cosmic vacuums that would one day suck up the entire universe and we would all die crushed in really strong gravity, and we would. But that's not what black holes are, and that's not how they work. You can sort of think of them as super dense zombie stars. They are no longer stars. They're the remnants of a dead star. At least the stellar black holes are. And they have very, very, very strong gravity, but they're not going to suck up the whole universe. They have stable points at which celestial bodies can exist and can orbit in a regular manner, just like planets orbit our sun. Unless you go past the event horizon here, which is basically the point beyond which you can't escape the black hole and you are doomed to get sucked in and just stay there and possibly view the birth and death of the universe through time dilation. That's pretty cool. I wouldn't do it though. So black holes that are formed, in case you don't know, they're formed through the gravitational collapse of massive stars. Like this one was once a type O star, which is a blue giant star. Once the mass of the star collapses after it burns through its fuel and the star's temperature isn't high enough to prevent it from imploding under its own weight, the mass basically condenses into this tiny, 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 tiny thing that we've never seen, really, but we know exists and creates these gravitational time-space anomalies, which are super cool. Black holes are way more complex than I can describe at this time. There's a book I've been thinking about reading called Black Holes and Time Warps by Kip Thorne. It looks cool. I think that would satisfy my black hole knowledge-seeking desires. So, as I said, this is a planetary system. TAMSA 1 is way out here. It is a Chthonian planet. I don't think we've discussed Chthonian planets yet. They are essentially the remains of the cores of gas giants. The atmosphere of the gas giant was stripped away through hydrodynamic escape, and it left just this super dense core that's probably rich in metals and minerals and would be, oh man, so cool. I wonder what we could mine there. However, TAMSA is still off limits because it's being assessed by the Fair Chance Act. It was discovered pretty recently, 2943. So, once the Fair Chance Act concludes that maybe life isn't developing in a black hole system, maybe mining rights can be explored, which I think would be pretty cool. Now, it's not the only planet in the system. There is one more if we zoom way out. Tamsa 2. Over here, it's a gas giant. It's about the size of Jupiter, as you can't see because it's not to scale. But what I mean is about the mass of Jupiter. It has a thick atmosphere and a dense core. And like its planetary sibling over here, Tamsa 1, it was a rogue planet. These are both rogue planets that were captured by the gravity of the black hole. Now, Tamsa 1 was probably ejected from its system in a nova-like event, which probably contributed to it losing all of its atmosphere. Tamsa 2, however, was ejected from its system through means unknown because it still retains its atmosphere. We don't know yet. Scientists in the universe are still trying to figure out exactly why it still has its atmosphere, where it came from, and only time will tell, figuring out what became of this planet system. Now, since Tamsa is so small, even though it's super, super interesting, I think that we do have time today to do one more system, which is another really interesting system. It's called Min. This one is a rogue planet, much like the rogue planets that were captured by Tamsa. It was ejected from its system through means unknown, and it's just kind of tearing its way through space with 4 moons that it's picked up in its journey. It was discovered at 2473 in an unlikely nexus of jump points, which is, let's see, how many jump points are in this system? We have 2 jump points, which is just wild because it's a planet. Like most jump points that we know of converge around stars. No one knows why this planet has picked up jump points. It's a cool science mystery of the Star Citizen universe. So its Jupiter mass, same as Tamsa 2. It generates its own heat, much like our planet, our gas giant Jupiter does, through the Kelvin-Helmholtz mechanism, which means as the surface of the planet cools, the pressure on the planet drops, and the surface shrinks, which in turn heats the core of the planet. It's like somewhere in the 600K range. Science. Its first moon right here, Min 1A, is an uninhabited rocky moon that has been strip mined a long time ago. There aren't any resources available. No one is sure whether it formed with the accretion disk that created Min 1 or whether it was just picked up in Min's journey through space. Could be an interesting question to answer. Min 1B is one of the most interesting moons in space, in my opinion. It, against all odds, is somewhat inhabitable because it has an incredible amount of geothermal energy that makes liquid water available on its surface. Now, it is still really cold, and it's not ideal for human habitation, but a couple of settlements have, in fact, been built up here. What's putting those settlements into jeopardy is the recent discovery of bioluminescent bacteria on the bottom of the ocean that clusters around the hydrothermal vents that help heat the planet. And so there is currently a debate going on about whether or not to apply the Fair Chance Act to this system. Cynics say that the reason that it hasn't been done yet is that there really aren't any valuable resources here, since the whole system was strip mined ages and ages ago. So people are like, oh, well, the government's not going to want to invest money in assessing this system because why would they? What money do they stand to make? So it might be bad for the bacteria on Min B. However, there are still some scientists there researching it, so they'll find out more about it in time, one hopes. Min 1C is very much like Min 1A. It is the smallest of Min's moons. Uninhabited, rocky, totally strip mined, very small. And where are you, Min 1D? I know I saw you somewhere. There you are. This guy is another tiny baby moon. It's not as small as a lot of the others. It's smaller than 1B, but it's bigger than 1C. It's pretty, it's an alright place. It's covered with impact craters. So if anybody wanted to know much about the history of the system, they could probably do some digging into the impact craters and figure some stuff out geologically. Which I think would be awesome. So, there we go. That's Min. Unlikely nexus of 2 jump points, rogue planet with moons tearing throughout the system. Just being interesting in space with its cool, inhabitable, barely inhabitable moon. So that is it for this week's Loremaker's Guide to the Galaxy. Thanks for watching, and I hope you enjoyed this incredibly science-y tour of 2 of the most interesting small systems in the verse. Goodbye.